Mrs. Shobana Subramanian graduated with a gold medal and additionally was the best outgoing student in her Bachelor's of Architecture batch. Mrs. Shobana, working as a senior architect at the Engineering Design Research Centre, L&T Construction, India's largest construction company. She has worked on various projects including hospitals, office buildings, residential, recreational to institutional projects. She has also attended 4 national conferences, 1 international conference and an international Indo-French workshop initiated by the UN Heritage on the urban morphology and architectural typology of the Karaikudi heritage, Chettinad.
Welcome to UGC lecture series for B Architecture. This lecture will be looking at the subject Building Materials, Unit 1, Bricks. In this lecture, we will be following contents. Firstly, we will be looking at what is a brick, okay? What are the different sizes, weights and what are the different parts of a brick. Next, we will be going into what are the composition of a brick earth, and next we will be looking at the manufacturing process of a brick, which includes several sub-steps such as preparation of the clay, molding, drying, burning. After that, we will be seeing what are the different tests for a brick to check what is the quality of the brick. Then we will be looking at properties and uses of brick, and next what are the classification, what are the different types of bricks available and what are the different classifications for them, and finally the types of bricks. So first, brick. Everyone knows what is a brick. It is one of the oldest material that has been used for building construction. It is very popular and it is also the leading construction material. Now, what makes it the oldest, the most popular and the most lead construction material? Mainly these 3 factors, that is, bricks are cheap, durable and very easy to handle and work with. These 3 factors make brick the most popular building material. Now, traditionally the bricks were sun dried. They were made out of mud and they used to be dried under sun. Then fired bricks came in existence. People realized that when they fired the brick, they had better resistance to weathering conditions. So, which made them a much more reliable brick for use in permanent building construction. Now, what is a brick? Brick is basically a rectangular piece of object, cuboid, which is usually in a size available that can be easily handled with one hand. The materials for a brick, the most common material is burnt clay, and also there are other different materials such as a mixture of sand and lime or Portland cement is also used to make bricks. Now, these clay bricks are the most popular, and bricks are application for bricks are several. It is used for making external walls, internal walls, even for structural elements such as posts or columns, pillars, even engineered arches and all, domes. So, application of a brick, you have a very varied application of bricks. Now, what are the different sizes of the bricks that is available? Usually, the size of the brick depends on the context or the locality where the brick is being used. There are many sizes available in market, but to get a common size, we have a standard size of brick. So, let us get into that. Now, there are 2 sizes of brick. One is the actual size of the brick and one is the nominal size. Now, actual size, for example, you see a brick here. The bricks, let's take the length as A, the width as B, and then the your depth of the brick as C, or the thickness of the brick as C. So, whatever A, B and C is, that is the actual size of the brick. When it comes to the nominal size, you include the mortar thickness. So, nominal size becomes A plus mortar thickness, B plus mortar thickness and C plus mortar thickness. Okay. So, now actual size. The most standard bricks, in those bricks, the A, that is the length of the bricks, is 2 into B, that is twice of B, and B and C are equal, or C is half of B. Okay. So, length of the brick is twice of the width of the brick and height of the brick is equal to the width of the brick or half of the width of the brick. Now, nominal size will become A is equal A is twice of B plus thickness of mortar, and B is equal to C or half of B plus thickness of mortar. So this is the actual and nominal sizes. Now we have a standard sizes of bricks, okay, standard bricks. These are called file bricks, most commonly used bricks. In those standard bricks, the size is 215 mm, that is 215 mm into 102.5 mm into 65 mm. That is the actual size. Now when you include the mortar thickness, it becomes 225 mm into 112 mm into 75 mm. This size of brick is the most commonly used brick in practice. Now BIS, Bureau of Indian Standards, recommends a modular size of bricks. These modular sizes 190 by 90 into 90, and the nominal size, which includes the mortar thickness, is 200 into 100 into 100. So usually when designing a building, we give a thickness to the wall. Majorly we use 200 mm as the thickness to the wall because we will be using modular bricks. In case we are using it's a standard size of bricks, we give the thickness of a wall as 230 mm, that is including the plaster. So you have the nominal size as 225 plus plaster on either side of the wall, thickness including all that, it becomes totally 230 mm thick wall. Now what is the weight of a brick? It is seen that 1 meter cube of brick earth, or earth that is used to make a brick, is about 1800 kilograms. So from 1 meter cube of brick, we can get approximately 500 to 600 bricks. So that gives an average weight of a brick about 3 to 3.5 kilograms. Now we know what's a brick, what are the different sizes of the bricks, what's the weight of the brick. Now let's see what are the different parts of a brick. Now you would have seen majorly the brick is laid on its bed. The image you see on your left, brick is majorly laid like this. So when it is laid like this, this portion becomes your header, the longer face is a stretcher, and then you have an indent on top, that is called the frog. Now parts of the bricks also depends on the way it is laid. So on your right, if you see, it is laid on its bed, it's called, this portion is called stretcher, and that becomes your header. When it is laid on edge, then the longer face becomes shiner and the smaller face becomes rowlock. When it is laid to stand, when it is laid like, the larger face is called sailor and the smaller face is called soldier. So the parts, the different nomenclature given to the different faces of the bricks depends on the way the brick is laid. Now for example, you see in these images, can you guess what is this part of the brick is called a stretcher? When you see the second image, so this becomes your stretcher and the smaller face becomes your header. Now in this image, you see, if you carefully see, you see certain bricks laid to stand, yeah. So in those cases, your exposed edges become sailor and soldier. Now you understand the parts of the bricks. Now we'll come to frog. What is a frog? Frog is an indent that is given on top of a brick. It is usually 1 to 2 centimeter in deep. Now the sizes of frog majorly used is 10 into 4 into 1. This 4 into 1 centimeter of frog is given in those standard size of bricks. Now why do we need a frog? See, bricks are laid with mortar. So the bricks have to bond well with mortar to create a monolithic and strong wall. So these frogs provide an indent where the mortar can come and sit, and it makes a key for the it creates a key where the mortar can bond well with the brick, and it has a stronger, it cements well. So this is the reason, the purpose of providing frog is to form a key for holding the mortar, and therefore the bricks are laid with frogs on top. How this frog is given? Usually bricks are molded, yes. So in the molds itself, you see the image here, this is a brick mold. Now you see there is a wooden piece provided in the mold. So when you put the clay in the mold and set it, and when you remove the mold, the wooden piece creates the frog. Now the size of the frog, whatever size of the frog you want, accordingly you can keep the wooden piece. So this is the frog. Now there are two things you have to remember when how to lay a brick when it comes according to the frog. the bricklaying should always be in such a way that the frog should be on top. And also the next thing is, frog is not provided for a 4 centimeter high or bricks with less thickness. Frog is not provided because it compromises on the strength of the brick and durability of the brick. And also extruded bricks, that is bricks which are hollow, even in them frogs are not provided because again it will compromise on the structure and the stability and the strength of the brick. Now we are saying frogs should be, while you layer the brick, the frog should be on top. Now why should the frog be on top? See, when you see this image, you see the orange portion shows you how the mortar is sitting in the frog. Okay, so here you see no voids, the whole thing is monolithic, and here you see the mortar, it's not filling up the frog. So this is what happens if you lay the brick with frogs on top, and this is what happens when you lay the brick with frogs facing down. So what is the difference between these two? Let me explain. So this brick is laid with frog in the bottom. This is one course of brick and this is the next course of brick. And if you have frog on top, this brick is laid with frog on top. Yes, now mortar happens. Yeah. So this is the mortar in between the bricks, and this is the mortar. Since it is on top, the frog is on top, the mortar tends to fill the gap between the bricks. Yes. Now what will happen when load acts on this? So when the load is acting on this wall, since there is a void here, this load tends to go like this. The load from here tends to go like this. And again here it tends to come, but since there is a void here and this cannot take the load, it tends to go like this. So the load actually works like this. What happens to a brick when the frog is laid on top? Load is coming like here. Yes, since this whole thing is filled and there is mortar here as well, you have mortar here as well. So when the load is acting, since it's a monolithic, this whole thing is a monolithic structure, the load tends to be distributed more uniformly. So this kind of wall is has more strength, is more durable, and than this type of wall, because it will create some structural issues which will be minor, which can become bigger and can create cracks in the wall. That is why frogs are always laid on top while you lay your brick. Now what is the composition of a good brick earth? Now we'll be looking at clay brick now. So what is the composition of a good brick earth for a clay brick? So for a clay brick, burnt clay brick, the major component is your silica. Now silica makes up about 50 to 60% of the brick earth. Now silica can be present in free form or mixed with something else. Free form as in it can be present in sand. Sand has a lot of silica content, so it will be present in the sand or as a mixture, chemical mixture with alumina or any other component. So almost more than half of the brick earth is composed of silica. Now what is the use of silica in brick earth? Silica helps a lot in avoiding the cracking, shrinking and warping of raw bricks. Warping means it bends slightly. So these kind of deformities are avoided when you use silica in the right quantity. And also silica helps in giving a uniform shape. It increases durability of the brick. If you use silica in excess, then it destroys the cohesion and the brick becomes brittle and easier to break. Silica is also used to give a good bonding between all the different elements. So when you burn the brick, silica melts and becomes more compact, and when it melts, it combines all the elements of the brick earth together and bonds them well. Now next major component for a brick earth is your alumina. Alumina is about 20 to 30% in a brick. It helps in the plasticity of the brick earth. Basically, when you're molding the brick earth, it should be it should be easily workable. It should not be either too runny or too thick for such that it will be hard to mold. So the exact amount of plasticity required to mold is provided by alumina. Also, alumina is also, you should not use it in excess. If you use it, it will make the brick shrink and warp during drying. The next component is your lime. It's present in about 5 to 15%. Again, lime also helps in preventing the shrinkage, and it also helps in binding silica. Now, excess of lime, what happens is brick loses its shapes if you use too much of lime. When you add lime to the brick earth, it should be in a very finely powdered form. If it is in lumps, what happens is when you burn the brick, these lumps also get burnt and these turn into quicklime. This quicklime is very reactive with water. So when this brick comes in contact with water, the quicklime inside the brick also reacts with water. The quicklime also comes in contact with water, and this quicklime reacts exothermically, and that will create cracks and compromise on the strength of the brick. So always when you are using lime on the good brick earth, you should make sure that the lime being used is very finely powdered. The next component is iron oxide, which is used in about 5 to 10%. Iron oxide is the component which gives that copper or reddish color to the brick. Now, if you use it in excess, the color becomes darker, it becomes blackish to bluish, and if you use less of iron oxide, the brick becomes yellowish. What quality does iron oxide impart to the brick earth? Impermeability and durability. Iron oxide basically increases the impermeability and durability of the brick. Also, it makes the brick strong, and it also increases the hardness of the brick. Finally, you have magnesia, which is used very scarcely, almost like just 1% of the brick earth is has magnesia in it. Magnesia is used to reduce shrinkage, and if you use excess of magnesia, it might lead to the decay of the brick also. Let us see at the bricks manufacturing process. Here we will be looking at the manufacturing process of a burnt clay brick. So, there are 4 major steps in the manufacturing of brick. The first one is preparation of the clay, preparing the clay. The second is molding, third is drying, and fourth is burning. So, preparing the clay. There are several steps for preparing the clay. You cannot just dig clay from the earth and start using it for manufacturing your brick. You first go through unsoiling. Unsoiling is basically removing the topmost layer of the soil. This topmost layer contains a lot of organic matter, impurities, leaves, dead insects and such stuff. So, this has to be removed to get a more purer form of clay from the bottom layers. Next is the digging. You unsoil it, and next you start digging out the clay or the clay sand. This can be manually done, as well as nowadays a lot of machinery is used to dig out the clay. Now, once the clay is dug out, it is spread onto a leveled ground, and it's dug and it's put in heaps. These heaps should be of about 60 centimeter height. Next is cleaning the clay. Even the clay, when you take it from the bottom layers, it still has certain impurities and certain plant roots and vegetable matter and organic stuff. So, this clay is first cleaned of all those impurities, and then the clay is washed and screened through meshes. Next you have weathering. Basically, in this weathering step, what happens is the clay is taken and it is left to expose to atmosphere. Now, during the process of weathering, the clay gets more soft and mellows down. Because we do the weathering at this stage, when you get the final product of brick from that clay, the brick will have a better resistance to atmospheric weathering, because it went through the process of weathering during the preparation of the clay. Now, the period of exposure to the atmosphere can depend upon the location where it is being done. It can be from few weeks to full 4 to 5 months. After the weathering, the weathered clay is taken and then it is blended. Blended is basically it's made loose. It is made loose, and certain ingredients like iron oxide and your magnesia, your alumina, and whatever else you require, all those ingredients are added on top of it, and then it is mixed mixed to get a harmonious product mixture. After blending, you do tempering. Tempering is a higher degree of blending. Blending is just first level of mixing. Tempering, you further mix the clay. Tempering is again, there are two types of tempering: manual tempering and mechanical tempering. In this, the clay is brought to a proper degree of hardness and it is made fit for the next operation of molding. So, both in manual tempering and mechanical tempering, there is a lot of mixing happening. In manual tempering, the water is required, the water in required quantity is added to clay, and the whole mass is kneaded or pressed under feet of men or cattle. Now, this tempering should be done extensively and exhaustively to obtain a homogeneous mass of clay of uniform character. In mechanical tempering, you use machines, of course. So, most commonly used machine for mechanical tempering is your pug mill. The major part of a pug mill is your conical iron tube. So, this is a huge tube which is sunk into the ground for about 60 centimeters to 1 meter. It is sunk into the ground and the rest of the tube is exposed. Now, the tube, inside the tube there is one vertical shaft which has, or you can even call it a vertical arm, which has several different horizontal arms. These horizontal arms contains knives or blades. Now, this vertical shaft is connected to a long arm. Now, this long arm is in such a way that it can be rotated. So, when the long arm is rotated, automatically the horizontal arms inside the conical tube also rotates. This rotation of the long arm can be done by mechanically, or it can be also animals. In earlier days, animals were used to rotate the long arm. The mixture after the tempered clay is put inside the pug mill. Now, the blended clay is put inside the pug mill and the long arm is rotated, which makes the horizontal arms inside also rotate. Now, when this is done, the clay is extensively mixed inside the pug mill to get a more homogeneous mixture. This mixture is then taken out via the tube or hole at the bottom, and then it is taken out for the processing. The knives inside the pug mill, they cut through the clay and break all the clots or lumps. So, when the shaft rotates, this thoroughly plugged clay is then taken out through this hole. The yield from a pug mill is the amount of clay that you get out of a pug mill at one time. We can make up to 1500 bricks out of that amount of clay. Now, next is the process of molding. Now, in molding there are two different types of molding: hand molding and machine molding. Hand molding, again we have ground molding and table molding. Machine molding, we have two types again: plastic clay machine and dry clay machine. So, let us look at hand molding. Hand molding, as the name suggests, the bricks are molded by hand, that is, they are done manually. It is also adopted where manpower is cheap and it is readily available for the manufacturing process of the brick. And hand molding also, since you cannot, there is not much yield, so it is done only for small scale companies. Now, you have hand molding. One of the major equipment for hand molding is obviously the mold. You see the mold. Mold can be of different sizes depending on the type of brick, that is the size of brick that is required. Usually molds are made of wood or metal, but majorly wood is used. Molds are rectangular boxes which are open at the top and bottom. So, a typical wooden mold should be prepared from well seasoned wood. Why? Because wood tends to absorb moisture and there is a lot of moisture in the clay. So, if the wood is not well seasoned, it will absorb the moisture from the clay and it will compromise on the durability of the brick that is being produced out of the mold. This is the elevation plan of a mold. You see there are two longer sides and one shorter sides. So, this longer side is extended on both the ends to create an arm this arm is used to handle the mold well. Now the longer side kept slightly projecting, and the strips of brass or steel are sometimes fixed on the wooden molds to make them more durable. At the ends here, to make them more stronger, the strips of brass or steel are kept. Now ground molded bricks, this is the most primitive form of brick making. This process of ground molded bricks is, first the ground is readied. The ground is made level and a fine sand is sprinkled over it. Why the sand is sprinkled? Because it will absorb any moisture. Also it absorb any moisture from the ground below. Also it will make the ground drier and more plain. Now the mold is first dipped into the water and then placed on the ground. A lump of this tempered clay is taken and it is thrown in the mold. It is thrown in the mold such a way that in the force it will go and fill the gaps inside the mold and all the corners inside the mold. Now and then it is set, by using of hands, it is pressed and it is set inside the mold. Now if there is any extra surplus clay on top of the mold, it is removed by something called wooden strike. The wooden strike is something like a knife. With it, the extra and excess clay from the mold is removed. After this is done, the mold is lifted up and the raw brick is left on the ground. The mold is again dipped in water and is placed just near the previous brick, and then the next brick is molded. Usually this process is continued till the whole ground is covered with bricks, or till the required number of bricks is achieved. The mold is supposed to, between each brick molding, the mold is supposed to be dipped in the water, but in practice it is not done like that. Mold is dipped in water only after every 5 or 6 molding is done. In this ground molded bricks, what happens is the bottom layer of the brick are rough because the mold is done on sand. So the sand texture, the bottom layer of the bricks get that sandy texture, and it is not possible to have a smooth texture on the bottom. Also the ground molded bricks are of better quality and with frogs on the surface are made by using a pair of pallet boards on a wooden block. Now this is an image of a ground molded brick. You see a person holding a wooden mold and he is molding, and you see these letters on top of the brick. This is actually a frog. Nowadays people also write the company's name instead of the frogs. With this we have reached the end of our lecture. To summarize what we learnt in this lecture, we learnt what is bricks, what are the different parts of bricks, what are the different parts of bricks, how it is named based on how it is laid, and the sizes of brick available, standard bricks, modular bricks. And for a good brick earth, for a clay brick, what is the composition? And in the manufacturing process of bricks, we saw the first step, that is preparation of the clay. We will be looking at the other steps in the next lecture. Now, from your learnings and your understanding from this lecture, can you answer the following questions? What building components or parts do you think are constructed out of bricks? I will give an example, walls. So, think of what other parts are constructed out of bricks. And do you think the brick is a good material to construct a load bearing structure? And a brick, do you think is a brick an eco-friendly sustainable building material? With this we are ending our lecture. Thank you.